And it is live. Another Friday, and we are again here with you. For you people watching live, and you people watching in the future. Hi Vlad, how are you?
Oh, good. Nice that we do it again. Yet another
Yeah,
Friday.
exactly. Today we're gonna do things a little bit differently. We will not have sections, we will dive into the main topic straight away. And today the topic is ECS Service Connect, in particular, how you could enable encryption in transit with ECS Service Connect and ECS Fargate deployment. I mean, that's always for a little bit challenging, and I think ECS Service Connect is it's making it easier, and it's a new feature that was announced on last reInvent, and it actually wasn't announced on last reInvent. It was announced in January this year, so it's rather new. But why should people care a lot?
Yes, it's a good question because, for example, if I'm a startup owner who is worried about the future, for example, what's happened with my startup, I also have to worry about any kind of compliance framework because if my company is working with data which require protection, maybe personal identity information, maybe I store person's emails, for example, it's often happen in a world. So, and in terms of European Union, there's two frameworks that will appear. It already exists, but they will apply it in the next year. Like one of them is Digital Operation Resilience Act. It's called DORA, and it could be big thing, but in the next year when it's applied and that companies get audited and tell, oh, here you have to fix this and that. And if you're a startup owner or a CTO who are thinking ahead, so it's time time to worry about it right now. And another one, it's NIS
These
2,
two.
Network and Information Security Directive. It's a second version. And in general, we would like to say that these rules become more strict each year. This
Yeah.
is but the direction that we see.
And this is because industry is failing to meet requirements of the general data privacy. I mean, you see data breaches left and right, and the government is getting fed with that, so they start to regulate and start to tell people how to do that. Exactly the same happened with PCI DSS compliance framework, right? So there was a lot of credit cards stolen online, and not only online, also on POC, like point of sale devices. And people would steal the credit card information, make the fake credit cards with that information, go spend money. No one liked that, and that's why PCI DSS standard came about, forcing companies to handle credit cards in a certain manner, making sure it's secure. And right now you could see that there is much less credit cards being stolen online. Like I don't remember my credit cards being stolen in the last 5-6 years. And the same were for the healthcare information in the US, for instance, like the HIPAA framework and like the NIST frameworks that implement it. That concerns PHI. So if you were in financial service or like doing the healthcare in US, you would knew that the encryption is a cornerstone. I need to make it done. It's like the basic requirement. The rest could just care less. GDPR kind of came about and made it a little bit more strict, but not strict enough, I would say. So it still wasn't like, I don't think people felt that's mandatory, but the new directives that coming in, they're tightening the screws. And it's not only the certain industries, they actually have a quite broad application. So that's why you should care. And if you're building something, the time for market is important, right? And re-implementing the network controls is hard later. So it might cause network disruptions and so on. So it's better to do it from the day one if you can. And I think with ECS Service Connect, that's something that you can do from the day one because it's very, very easy.
Yes. So, and if everything of this sounds interesting And please like and subscribe to see more content like that.
Yeah, there will be more. But let's dive in and see what is ECS Service Connect is, and if there are any alternatives. I actually dug up the slides from reInvent, and yes, I'm gonna share the screen, and I do know that it's better to share when you have two monitors, but not today. So here is alternatives that you had before. You could use Amazon ECS Service Discovery, you could use Elastic Load Balancing, and AWS App Mesh. So you could use those to interconnect ECS services, but you couldn't use all of them to implement encryption. Like, your only option was App Mesh. And let's take a look how they worked, because that will help us. So with Amazon ECS Service Discovery, with Cloud Map, your ECS service would register the tasks in Amazon Route 53, and you will get DNS names that other services can use to connect. You had no traffic telemetry, it's very basic discovery. There is also DNS lag, so there's actual tasks that wasn't DNS might not be alive any longer, so that happened.
It just DNS automation, it's what ECS do. Just if service healthy, send the API call. If service is not healthy, another API call to DNS system. Very straightforward, simple.
Another option that people do quite often, they just register all the ECS services to the same load balancer, and then services would call each other going through the load balancer. That adds additional hops. You could implement security like this, going like this, oops, but then you will not have encryption between load balancer and ECS task in most cases, unless you implement that natively in your ECS task, which people usually don't do. And then you had App Mesh that would add the Envoy sidecars. They will also register in Cloud Map. You will have App Mesh configuring them, and it was quite complex. You had a lot of capabilities here, like you could do the fine-grained traffic controls. Actually, it wasn't like a lot. Like when it comes to the traffic shaping, App Mesh didn't have a lot comparing to other service meshes, but it could help you to implement encryption and also MTLS. But that required you using private CA in a long certificate, not in a short-term mode, because like in the short, you only pay 50 per a private CA, but like in that mode you would pay for 100, and that's like per one, and you might want to have a couple of them. So that could get expensive, and that's why AWS,
For App Mesh, usually people see Envoys like as in this picture, and everyone expects that we can manage with Envoy, and Envoy is like this very powerful, open source project, and people expect to do a lot more. But Mesh is quite limit us to a certain feature what we can control and manage, and maybe in some cases it's enough, especially if you decide to make a completely closed mesh, if we know exactly to which our services our service talks. So but as Andrei mentioned, it's a bit complicated, moving things around, a bit harder to implement TLS, but still possible. And also App Mesh exists in the past before the next solution appeared.
Yeah, and usually you would want to go with App Mesh if you need to connect multiple type of computes. So for instance, if you have something running on EC2s, something running on Kubernetes, something running on ECS, then you can use App Mesh to connect all of that together. But if you're using only ECS, then I would say App Mesh would be overkill. And like also if you need those complex networking scenarios, which you could also implement, like for instance, header-based routing, you could just do that with a load balancer. So you don't really need App Mesh for that. So let's take a look how people usually do that, like the typical scenario. I have a couple of diagrams here. So you would have people coming from the left, going through the internet gateway, coming to your VPC, you would have the ILB, and usually like doing HTTPS here from the client to the load balancer is easy. You could do that through ACM and issue the certificate there, but you never get the keys, so you only get the certificate, and you can use that certificate on the load balancer. And load balancer will do something that is called TLS offloading or SSL offloading. It basically will decrypt the traffic and send it unencrypted all the way down. And that might be a problem because if you have someone's... Yep.
Also mention that it's what we usually see as a client, or what if we are CTO or startup owner, what our clients see. They see our website, which have HTTPS, browser shows everything is fine, we are good. And we usually mention like traffic is encrypted end to end from the client load balancer. But this diagram actually perfectly show what's happened next.
Right? Exactly. So the problem here is that you might have a EC2 here sniffing the traffic from the VPC and capturing everything that passes through here. So that's quite easy to implement. And that's why it's a problem. And so generally when the data traversing untrusted network, yes, it's encrypted, but inside VPC, like if you still think in perimeter terms, it's unencrypted, and that's a problem. We should be moving towards more zero trust approach and encrypting everything. And we will look at multiple scenarios with ECS Service Connect and where it works. So the most typical one is encrypting traffic between two ECS services, right? So that's easy. But you could actually use it for more. You could also use it to encrypt traffic between load balancer and this service, or like any other service that is being called as a target for load balancer, because it will be serving the SSL port. So you could switch your load balancer from HTTP connection to HTTPS. That works. Then the last hop to the database. Yeah, this is where Service Connect will not help you, because that's database that needs to provide you with the cell connection. But it's very, very easy to do, and most of the Amazon databases will provide you the SSL endpoint by default. So ideally, you would see something like that. This is where you want to be.
Database side, it's not that hard. Sam and Ray mentioned it's easy to implement. It's work. It's have a multiple modes. It's have a way to migrate. Like it's not the permissive mode, so you can do it in multiple steps. Yeah, it's straightforward.
Yes. So, and when you watch the presentations, usually you would think, okay, so it all sounds good, but how will it fail, right? How will it work in particular? And this is what we're going to look at. So if you ever thought, is ECS Service Connect for me? We're going to show you how it works, how to deploy it, and how to enable encryption, and what things that you need to consider there. So what we have today for you is a little bit demo, and we start from the infrastructure perspective. I have an account here, and I have a load balancer, very typical to very similar to what we had on the picture. And if you haven't seen, AWS recently added resource maps, which are very handy. So we have HTTPS listener, so the traffic will be encrypted, and it will be decrypted and passed to the target group, and then it will be passed to the ECS service. Easy peasy. And our target groups, we have only one. The name could be better. We cannot really tell what's going on here and where the traffic goes. We only know the address, and we could see that port is 80, and from here we could start to deduct that it's actually unencrypted. We have ECS cluster with 3 services. We have a web serving as a front end and reverse proxy to cat and dogs. We're gonna see that live in a second. And we also have a cloud map. So So we have a cloud map namespace, and we're using the typical ECS service DNS-based discovery. So you can see it's discoverable by API calls and DNS queries, which means that we will have DNS names for those. And let's actually take a look if it works, right? So I do have also a EC2 tester that we're gonna use to ping those. So, and I'm gonna use SSM Connect to connect to it. You shouldn't be using SSH in 2024. So I get connection in the browser to the machine, and I could now check that I can connect over HTTP to dogs at ECS sample port 80, which is not really needed, but let's see. So yeah, I can, and I get the HTML back, which means that I could resolve this DNS name, and this is private DNS name registered by AWS Cloud Map. So AWS Cloud Map has this domain, and then each ECS service will register itself, and it will register its tasks. So it will keep updating the IP addresses so we can resolve it. And we also have a front door. Hopefully it still works. It does. So we have this address, and we have a little bit of JavaScript going on here, not important. We could also reach those as the pass. Right, so now the service works as a reverse proxy, right? So we have the front serving this, but we could also, this is iframe, so we could also see the services behind. It's very simplistic. Usually this front end would live in a cloud map, or cloud front, and then the services behind them would be available via the ILB. But for this demonstration, we actually need to have two ECS services talking together, so that's why we have it this way. Right, so we are ready to deploy, right? We have our services ready, and we could do that via Terraform. We have a Terraform config, and I have it here. So just to make things smooth and simple during the demo, I have the one flag, and I'm gonna run plan first. And that's important because when plan is complete, you will see that we will update our ECS services, but we will also attempt to delete the ECS service discovery. And that's important. So like you see, this is service registry. This is how we connect ECS service with a cloud map. We're telling that there is a service that where you should register. And I already have Service Connect pre-configured, I just have it disabled. And that's what will happen for all three services. But we also are going to delete those cloud map service discovery instances. And that's important because when we enable cloud map will try to register exactly the same discovery services, and if they exist, it will fail and you will not enable Service Connect, and the Terraform will tell you it's enabled, but when you go to check AWS it will not, so you would have to redeploy. And I will not let you suffer through that. We kind of already know, and that's the first consideration, which makes it a little bit hard, because if you're relying on this and you have a live traffic and you're just dropping the DNS name, well, your clients will not be able to resolve them.
This is a case of migration, you know, and you can create, I guess we can create a new service nearby, do this, and then switch the traffic. It's a infrastructure migration. But it's
technically you could register a second service that will stay, like will have a different name, right? And then switch the code to the new one. then enable Service Connect, switch the code again.
Yeah.
It's possible to do, but
You
here
know,
we try.
it's a
Yeah,
good example why it's hard to change after. Like I said, we, in the beginning of the video, we talked like I said, it's good if you get it to day one, right? So if you go with the ECS Service Connect from a day one as a new organization, you start,
yeah,
you be good. You doesn't need to struggle with the issues if you have more and more multiple microservices.
yeah,
It's,
exactly. All right, so I think we did delete all of them. The docs doesn't want to go away. How about you go away? Yes, now all services are gone, no instances here. Let's also pay attention to what's going on here. So if you do web and check tasks, I have only one running, and I have my app container, which is just simple HTTP server, and I also have GuardDuty agent. You don't need to pay attention to this one for this presentation, but it's good to have it running. And actually, we now deleted the DNS name, so this one should actually start to fail, I think. Yep.
yeah.
So there is some DNS caching, but some already failing to resolve, and we could actually do the same here. So we could try to call docs again, and we cannot resolve it because we deleted the cloud map services. So now we are ready to go. We're ready to deploy. And we're gonna say, dear Terraform, go ahead. Load, approve. Don't wait for me to say yes. All right, so that's gonna take a little bit.
Yeah, right. Because in this example or demonstration, we deploy all infrastructure at once, so all migrations.
Yes, and if we get lucky, we will see a next problem that we need to cover. So
okay.
the services will start now running deployments, and the order matters here.
Yeah.
And I will explain why. So let's go back to this picture. So in the Service Connect, when you enable Service Connect, you will get additional sidecar running together with your service, and that will be Envoy proxy that will be responsible for the DNS resolution, or like for the service discovery, I should say, because there will be no DNS. The Cloud Map service that ECS Service Connect register is only API based, so there will be no DNS name. And that's why you need this Envoy proxy to resolve the IPs, to do the traffic routing, to do repeats, and to do the encryption. So you have this situation. You have service A and service B. And service A needs to know where service B is. So what you would typically think, okay, I'm gonna deploy service A first. I'm gonna enable ECS Service Connect on service A first, because then I will get the Envoy proxy and I will be able to resolve where service B is no matter what. Is it DNS based or API, right? You do that and everything kind of works. But when you deploy ECS Service Connect to service B, your service A stops to work. And that could be a head scratcher for many people. When I first saw it, I was totally confused. Everything worked and now it doesn't. And like, what's going on? And I appears so that when ECS task starts, the Envoy proxy fetches available services that registered in ECS Service Connect only once. So if you add something after, you need to restart service A, which makes migration complicated. You need to plan it through. And let's see where we are.
We can also mention that in the past, in UpMerge, where it was quite a similar issue, but then UpMerge become more and more mature. And I think at the moment when you are a startup owner or CTO implement that solution in the future, it will be more mature, and AWS finally teach Envoy to fetch configuration maybe every
Maybe, but
5
we're telling it how it is today, right?
minutes.
All
Yeah,
the
but
problems, so you are aware. And look what happened here. We deleted services, but now we got new ones, and you can see here in description it managed by the ECS service, and it's API calls only. If you go to docs, I could see that I have the service instance registered, but I cannot resolve it because it's only API based now. And that's another thing to consider. If your developers used to use those DNS names, they will be gone. So you might want to create additional namespace and have that as in parallel for developers, for instance. So that's another consideration. Let's see if you have deployments completed. Yeah, I think everything seems to be completed. Let's see if that works. So the
good point with API only, because I think we created the namespace in a hybrid mode. It's a DNS plus API, but services itself was automatically registered in API.
So I think this is exactly what I've been talking about. So dogs can be resolved fine, but cats, I think cats is failing to load. And how do we fix that? We need to restart web container or redeploy it. So the nice way of doing that is to go to update service, force new deployment, nothing changes, and that will redeploy web, and web on a startup will learn that, well, there is cuts. There is also cuts that you can resolve. And you can see now we got a container sidecar, and you cannot manage it. You don't know where it's coming from. You know nothing. With AppMesh, you're actually deploying this container yourself, I believe, and you configure there.
You deploy with Envoy, you pass environment variables, you tell where is the mesh virtual node, where is the configuration. So you do the whole thing, but now there's no need to do it any longer.
Yeah. So with ECS Service Connect, it's all taken care of. And another thing that you are getting that you usually don't have, and I failed to show you, like usually without Service Connect, you will have this. You will have CPU utilization and memory utilization. But you will also get additional monitoring with ECS Service Connect. And you can see I had Service Connect before, then I deleted the services to demonstrate you the migration. Now we have it again, and I could see the network activity, I could see the requests. I see I had some redirects. They're actually getting quite a lot, and you can see I can even see my targets where I'm send the traffic. So that's quite nice, and you're getting this out of the box, which is very nice. So I hope that deployment will be done.
That could be integrated with the X-ray. It's a moment if it's not yet integrated, because it's,
I'm pretty sure it's coming soon.
Yeah, because AppMesh was integrated.
All right, so the old task is dropped. I believe it's draining from the load balancer now. We should be probably getting the new one. Let's see if that works. And docs works, and cat works again. You see, we restarted the service, the web. It learned about the cat service that is now registered in Service Connect, and now it works again. That is good. So the next step is traffic encryption, but let's first validate that we don't have it, right? Because if you are, as infrastructure engineer says, I enabled encryption, and well, you would need to be able to prove that, right? You want to make sure that it's actually so. And we're gonna use docs again. Let's use cats for the change. So we make some cat lovers happier. Oops. Apparently I ran out of my SSO session. Sorry about that. So back to the cats. So now, in order to connect to the cats, we actually need to get the IP address of the cats container. So where are you, cats?
Yeah, it's also a similar thing we can get is a API call to Cloud Map because it's available with API, but now we just make it simpler to demonstrate that it's the exact requirement container.
I actually have also the setup for the traffic mirroring to show that it's actually encrypted, but yeah, it doesn't work exactly as I want in this setup, so we would have to rely on CURL instead. Next time. So we're gonna be doing this. So we're gonna go again, and now we just use IP address. It's possible to use AWS CLI and resolve it, but so the same. We are getting cats. It's possible to connect. So let's enable encryption for the cats. For that, you would need to have some additional stuff. One of them is a private CA. Private certificate authority, that's what we want. And I have one created, and you can see those details are not very important, and you also should know that it will be the blog post based on this demonstration with all the details, how to configure it. Like when I resolve the comments from my lovely colleagues, it's gonna be live, and that will contain configuration for the private CA. So you will be able to repeat exactly the same what I'm doing right now. So don't worry. And also the Terraform will be publicly available. So I have this private certificate authority, and I need its ARN. I'm gonna go to cats.
Yeah, I could mention that for private CA, usually people scared about the cost because, oh, I am just experimenting. Why is it supposed to pay 400 or 50 per month because it's monthly based? But no worries, if you not use it for a whole month, if you just disable it today, you will charge it only for a particular period of time if you not restore it.
Right. So look, I'm doing that through UI because the model that I'm using right now for ECS service actually does not yet support encryption in transit, but in my blog post I show how to add it. Here is a Service Connect. We have it enabled, and I failed to say that you can be in a client side only. This way you will still get the Envoy sidecar, but if it will only be used for egress traffic. With client and server, the Envoy will intercept incoming traffic and outgoing traffic, right? And this is how you make it possible to encrypt it, because the encryption will be not available if you're only in the client side only. But you might want to have some services that, for instance, terminate TLS natively. Like those you would probably want to run in a client side only. And there is a small tick box, turn on traffic encryption, and you need to have a TLS role. This role is for ECS to be able to use the private CA. And here we need to give it an ARN of the private CA. And I cannot see any private CAs here because you might notice that the account ID here is different. So it's a shared private CA that I created in another account. That's it. Basically, we need the role, the service role for ECS to use the private CA and create secrets. And we're gonna click update. So now we got a new deployment started. We will get a new task that will have its traffic encrypted. Meanwhile, we could take a look at Secrets Manager. Why would we go to Secrets Manager, you might ask? Because we will get this created. You see, this secret is linked to ECS service, blah 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 cats, and Service Connect service. So the way it works, ECS on your behalf, when you deploy the encryption in transit, will go to private CA, it will issue a certificate, and it will store certificate in a secret. And this is how, when you redeploy, you will be able to reuse the certificate. And ECS Service Connect will be responsible for rotation of that certificate. So because our private CA is configured in a short life cycle for the certificate, so they valid only for 7 days, the certificate will be automatically rotated by ECS every 5 days. And you don't need to be worried about certificates expiring, because this is from private CA, and when ECS Service Connect establish TLS connection, it does it in secure mode, if you like. So it's the expired certificates will still work because they use for the traffic encryption, not for the validation of that who it is, right? Because we know who it is. And we could even see the secret value.
Yeah, it's a private key inside.
Yeah, so you have the private key and the rest. Let's see how our deployment is progressing. We already got the new container started. Let's see its IP address. So it's 198. Alright, so let's try this. I'm getting empty reply from the server. We are connecting to the same port, but it's cut off. So we're gonna do HTTPS instead. And we see exactly that. So we have a certificate coming from the private CA. So CURL is not aware of its CA. It's not in a root trust. So that's why it's considered self-signed. It typically is. So in order to connect, we have to use -key, which is like insecure, don't do strict verification.
We can add, but if it's our network, we can distribute with private CA.
Yeah. You could add that to the EC2 instances and to containers if you want to.
Yeah, it's possible.
But see what happens here. We are connecting and we have TLS 1.3 handshake going on. We will not dive into this, but that's exactly our private CA certificate. See, it was.
Yeah, it's the same subject.
See, and ECS FivexL IO, and we could see it's a certificate result, chain, the ciphers used. And you will also, like, if you check the certificate, you will actually see that it's issued for the cats at ECS. So it actually has cats at cats.ECS sample as its name. And we're getting the same HTML back after we establish secure connection. You see, we are getting the same HTML. But how about this? Will this still work? What do you think? So docs works. Cats works still, because you see the web is able to use its ECS Connect sidecar to establish now TLS connection to the cats, get the picture in HTML and present it to us. We could do the same for dogs, but that will be pretty much the same as for cats, so we will not do that. Now we achieve this. So the communication between web and cats is secure. How about ILB and the web? Can we do that? Yeah, let's try. So we're gonna do exactly the same. We're gonna do that from the console. Some ClickOps for you here. I think we would do the pull request to the model to make sure that it's supported, so you don't have to go through those hoops. That's not what I want. I want to have ARM of this thingy. And that's why it's much easier with Terraform, really. You don't need to go around and copy things. So now we have our web redeploying. And the interesting part about that it's gonna start to fail its target health checks. So if we go to the target groups,
Target group is thinking that it expects
yes. Yeah, we go to health checks and we could see HTTP here, right? And we need to change that so it works. So we need to change that to HTTPS. And now it will pass the health check, but there is also this part.
Yeah.
And this one you cannot change without deleting target group. You have to recreate the target group. So in order to recreate the target group, we need to delete it from the load balancer. We need to delete it from the listener. And as you can see, this could be destructive. So again, you would need to plan that.
Yeah, so we mentioned before, just create yet another service, deploy all the changes there, add it to load balancer as another rule.
Yeah, it's possible, but if you are a cowboy and like to shoot from the hip, know that it might go bad for you, and you will cause the service disruption that we probably don't want. So we don't have a target group. We're gonna recreate it, and for that I would have to tweak Terraform a little bit. We go to ILB, and in the ILB we have our listeners, right? And we have HTTP listener forwarding to HTTPS. We have our HTTPS listener forwarding to our target group, and here's our target group, which needs to be HTTPS target group, and the protocol needs to be HTTPS here as well. So let's rerun Terraform. And the thing is, you might now ask, will Terraform revert the changes we did for ECS Service Connect encryption? No, it will not, because the model is not aware of the configuration. It's not checking really. So what's gonna happen is we're creating the new target group, we're updating the listener, and we also updating the web, telling it you're gonna have a new target group to register it. And that will cause a new deployment. We will have to wait a little bit, but if everything goes according to the plan, then we should be able to get this part. Another point I need to bring, which is important, and this point is about your load balancer listener. And so here, your HTTPS listener, you need to go to security and check your security policy. That's important because security policy defines what security policy will be used for the target health checks. And security policy defines what ciphers are supported and what TLS versions are supported. So you need to make sure, for this to work, you need to make sure that your LB security policy is TLS 1.3 based, because then you will have the backend target policy supporting TLS 1.2, and that will be enough to work with ECS Service Connect. It's a little bit complicated, but that might cause your health check failing. So if your health check failing, you switch everything to HTTPS, go check this one, because that might be it. And I will have a links to the documentation in the blog post explaining that. And another thing to know here is that your target group
in the future it's higher policy. So if you're struggling with issues in the future, just check whatever highest policies at the moment if you're watching the video. So maybe things are changed.
Yeah, so it depends on your clients, really, right? So this one in particular, if you search for it, that's for your network load balancer, but I believe those will be for so policies. So here you could see the TLS version supported, and you can also see a cipher supported. So I'm using this one, which pretty much supports all the ciphers, even those that could be considered insecure, like those. So ideally, you would go with this one, which is default. You see it supports less stuff. I think this one's supposed to be secure, but yeah. So this one is better, but this one gives you much more backward compatibility if you want to. That's why I'm using that one in this particular case. Let's see, the web is running in progress. We have tasks. Healthy 50 seconds ago. Let's take load balancers. Actually, target groups. We should have the new one in here. Yep. Now we have HTTPS to the target. Health checks are HTTPS, and we have a healthy target. So everything works. Let's see that we still can. Yeah, that seems to be working. So now we only need to redeploy docs, and we will get HTTPS all the way. We could also double check the web if you want to, really. So let's do that just to drive the point home. So that was the IP address for the web. And you can see we basically getting a front page with my mighty JavaScript functions that let us change the iframe. Yep, that's how it is. Yes, so what I was also saying about the listeners. So I'll be listeners doing the target group. I'll be doing non-strict check of the targets, which means that it will basically does CURL -k. It's not so for network load balancer. Network load balancer does strict verification of SSL certificates, and you will not be able to switch to HTTPS. At least today, I have a very long running thread with AWS support. So the best they suggest to me is just to switch to TCP health check for NLB. And I couldn't get HTTPS working there because of those strict SSL checks on NLB target groups.
It's probably because we can't add in our own CA to ILB or NLB. We can't do it at the moment. So
but it's kind of interesting, right? So I'll be doing non-strict verification, and NLB doing the strict verification.
Different levels. But maybe at some moment they AWS had the possibility to add, custom CA inside ILB configuration, and then you can do a strict checks. So,
right. Our marketing director asked us to do a short video, 20 minutes. Yeah,
we did.
We nailed it.
No, we did a short video first to explore the problem, and the rest of the technical details, it's kind of optional. So if someone likes to look technical details, watch it. Not
if you reached to this point, you could be considered true fan and a geek and tech personas like us. So we appreciate your attention. Oh well. So that was a deep dive into ECS Service Connect and all the ways how migration to ECS Service Connect can go wrong. You have been warned. Plan migration correctly, and we believe it's a very nice feature which gives you security, additional observability, and no maintenance overhead. So you basically you tick the box, done. You see how easy it is, and you're compliant. What else to wish?
You can mention that it's hard maybe in the beginning when you build things, when you prepare infrastructure, when you code it, but when it just works for years, it's like you invest your time, and when you get the benefits, sure.
Yeah, and actually that's another reason why we're doing the stream and the blog post. When I was configuring that, I found a very limited amount of documentation explaining how it works, how to deploy, what are the problems. So we decided like, well, we're doing that for customers now, we are facing those problems, and let's just have a blog post and help other people, because the more people are secure, the better for everyone. Because like there could be services out there handling my personal data, and I want those services to be secure. So I'm doing it for the public good. Be secure, stay safe. Oh, done. I'm gonna press the button. I see you next time, Vlad.
Bye. Thanks for the demo.